Let me
And
open
I
up
think
a page here that I can start writing on. Just a second. If you can verbalize it, I will write it and we'll try to solve it.
was that factoring?
Yep.
Well, that's
Do
perfect
whatever
because that,
you want to do, Jameson. You kind of are the director.
that's exactly what I wanted to do was factoring.
Okay. Oh, you mean what I had on there was factoring? Yes, it was.
Yeah.
But it's better if you give me the problems you're supposed to factor.
Um.
That was another student that didn't have a book, didn't have any problems, and I started going over factoring with him. Because if
Okay.
there's one thing you need to do in algebra, it's be able to factor.
Yeah. Um. Let me pull up some problems.
Okay. They teach factoring all kinds of different ways, depending on where you go
Yeah.
to school. They might have taught you something called the California method or the diamond method or something that looks like this, or we put numbers there, there, and there.
Yeah.
In
That's what
all
we were
honesty, I
taught.
don't
But
like any of them. I hate them.
yeah. The
They're overly confusing. They're
yeah.
more complex than they need to be. And
Yeah.
I have a real simple way of handling simple quadratics.
All
The
right.
difference between a simple quadratic and a harder one is if the coefficient of the x squared term is 1, then it's going to be a simple quadratic. And you
Hmm.
don't need any of those exotic methods.
Yeah.
If the coefficient is something other than 1, then it definitely is a harder problem to factor. Not
Hmm.
impossible, but it becomes more of a trial and error process. But as long as that coefficient is 1, I can show you a very simple way to handle those.
Um. I have two problems here at the moment.
Okay?
The first one is x squared minus 7x minus 18.
All right. Let's talk about this process. Factoring is the reverse of foiling. You remember, did they teach you FOIL?
Yeah, but I don't remember it very well.
Well, let's go over foiling then, because that's a key thing here. Let's FOIL something. Let's multiply x plus 2 times x minus 7. Okay?
Hmm.
Foiling stands for first, outside, inside, last. But
Okay.
really, an easier way to remember it is whenever you're multiplying, just do every term by every term. Start with your left, multiply that, multiply that, go to your right, multiply that, add everything together.
Hmm.
So what does that give me? It gives me x squared minus 7x plus 2x minus 14, which comes down to x squared minus 5x minus 14. Okay, so that's the quadratic that would be produced by multiplying two linear factors.
Okay.
What we're doing is going the other direction. We're giving you the quadratic and they want you to separate it into these two linear factors. Well, that's not that hard. I'll give you a simple, in this problem, it's 4 steps. And you just have to remember all 4 steps. That's all it is, and then you'll never miss one of these.
Hmm.
Okay? First step, split up the two x's. In other words, when I multiply these back together again, I'm going to get this x squared term here.
Okay.
So that's always the first step. Split up the x's.
Hmm.
Second step, determine both signs. The fact that I am looking at a negative 18 constant tells me what? What do both signs have to be?
Negative.
If they were both negative, that would be a positive number.
Oh.
If they were both positive, that would be a positive number. So the fact that that is a negative number means the signs have to be opposite.
Okay.
One has to be plus, one has to be minus. In this particular situation, it doesn't matter whether I go plus minus or minus plus.
Okay.
Okay, that is the second step. Don't figure out one sign, figure out both signs. The third step, relatively simple. I need factors of 18 that subtract to the number 7. Now, where do I get that from? Well, factors of 18 is pretty clear. The fact that that is a negative sign means they have to subtract. That's what that means. To the number 7. Don't worry about minus 7. We just need factors of 18 that subtract to 7. What are those two? Here's factors of 18. Start with 18 and 1. We'll try cutting 18 in half, doubling 1. Try cutting 9 in thirds. Increase that. So those are all my factors right there. Which two subtract to the number 7?
9 and 2.
Okay. That's step 3. Step 4, take the bigger of those two factors, 9, and put it with the sign of the middle term. So the 9 has to go there. 2 has to go there. That's how you do it. Let's try another one. The best way to do factoring is just for me to show you how I do it, and then let's just try some and let you do it.
Okay.
It's another one. Let's keep them until we get this method down. Let's keep them all elementary, meaning only give me ones with a 1 in front of the x squared. Once you get that down, then we can go up.
Okay. We have x squared minus 9x plus 8.
Let's go through. This one only has 3 steps. It's easier. If that's a plus sign, it's only going to have 3 steps. What's the first step? It's always the same first step.
Put in the x's?
Split up the x's. By splitting them up, in other words, sometimes you're going to get a problem like this. Okay? And when you split those up, one of them has to be 3x and the other has to be x. In other words, when you split them up, they have to multiply together to give you that.
Okay.
So whenever it's a simple quadratic like this one, then it always splits up x and x. Okay? Second step.
Second step is find the signs.
Both of them.
Yeah.
What do they have to be? We can tell by looking at the sign on that and the sign on that. First of all, how can you get a plus 8? What do both signs have to be?
Negative?
Well, they have to be the same. So either minus minus or plus plus. And the fact that the middle term is negative means they have to be minus minus. In other words, once you have figured out that they have to be the same, then whatever the sign on the middle term is, that's what they have to be. Now, what's the third step?
Find the numbers divisible by.
Now, factors, use this terminology, factors of 8 that add, because that plus sign, to the number 9. Well, here's our factors of 8. 8, 1, 4, 2. That's it. Which two add to 9?
8 and 1.
And notice there's no further decision. This was a three-step problem. Doesn't matter if I put the 8 there and the 1 there or vice versa. Now, let's just do one more thing. When you're checking to see whether you have factored it correctly, you could go ahead and multiply it completely out using FOIL or ET, whatever you want to call it. Multiply every term by every term. But the fact of the matter is that I know the x squared term is correct. It's too easy to design this. The x squared term is definitely correct. I also know that those two numbers multiply to 8. So I know the n term is correct. The only term I'm not 100% sure about is that middle term. Now, the middle term comes from the O and the I of FOIL added together. So the inside is minus 8x, in other words, minus 8 times x. The outside is minus 1x. Add those together, you get minus 9x. That verifies we did it correctly. And that step, it may seem in this problem that that's just a step you do to check your answer. But the thing is that when you start getting into harder quadratics, where it's, a number other than 1 in front of x squared, this is a critical part of figuring out the answer.
Right.
So get used to this visually. You're going to end up doing this a lot. Not just to check your factoring, but to actually solve the factoring when they get harder.
Okay.
Give me another one. You can go harder if you want. You'll notice that was only 3 steps because we didn't have to decide which number went with which sign. The first problem we had to figure out which number went with which sign, so there was a 4th step.
Yeah.
That one is as easy as they get. They're never shorter than 3 steps. They're always at least 3 steps.
Okay. Okay. Negative 2x squared minus 6x squared plus 56x.
Sure that's right? Is it minus 2x squared or minus 2x cubed?
Oh yeah, cubed, sorry.
All right. So what we're looking at here is factoring also. But when you're looking to factor something, what is always the first step? In other words, the first step isn't always breaking it into 2 linear factors. Sometimes there's a better first step. What's the best first step here? If somebody gave you this, always it's the first step, always. And that is to look for a greatest common factor.
Right.
What's the greatest common factor in this equation? In other words, what is the largest thing that divides evenly into every term? Minus 2x. Notice that I can divide every term by 2, and I can divide every term by x. Now, what's that leave behind? When I divide that by minus 2x, what do I get?
Negative 3x.
No, you're dividing it, that term, you're dividing by negative 2x. So what is that? X squared.
Oh, okay.
Okay. And when you're doing these problems, especially with greatest common factor, after every single step, you should check. In other words, I'm saying that minus 2x times x squared is equal to minus 2x cubed. Is that correct?
Yeah.
Then I've done it right. In other words, And now take that term and divide it by minus 2x. What do you get?
Negative 3x squared.
You actually get 3x.
Oh, okay.
Here we go. Here, I'm going to do it down here. Here's what I'm doing. Well, the negatives cancel. The 6 over 2 becomes 3. And the x squared over x becomes just x. So plus 3x. And again, I'm going to multiply that times that to make sure that I got what I started with, which was minus 6x squared. And I do. In other words, when I multiply minus 2x times plus 3x, I get minus 6x squared. Finally, we have to divide that last term by our greatest common factor, and that gives us negative 28. Okay? Now, if you had all day in the world, what you would want to do is just go ahead and check this. In other words, distribute the minus 2x to every term. Make sure you get what you started with, and you will. The advantage of doing this is that we're always setting it equal to 0. And now notice this quadratic right there. That can actually be factored. That's a simple quadratic. Go ahead and factor it. These are 4 steps. I'm taking just the quadratic that I underlined, and I'm going to separate it into 2 linear factors. First step.
Find the variables.
No, you might want to write this down because it's always the same 3 steps. You just got to memorize.
Right.
First step is to separate the x's. It's an easy first step. It's always the same first step. Now remember, that minus 2x is sitting off over here to the side and is not important. I'm not looking at that minus 2x at this point. I'm merely trying to factor that quadratic. Second step.
Find the signs.
What are they? The fact that that's a minus 28 means what about the signs? They have to be opposite. You cannot produce a negative number if the signs are the same. You always, in other words, when you multiply a minus times a minus, you get a plus. When you multiply a plus times a plus, you get a plus. So the fact that we're looking at minus 28 means one of them has to be plus, the other one has to be minus. It's the only way you can produce a minus 28. Third step. In other words, splitting up the x's is the first step. Determining both signs is the second step. The third step starts with factors of 28 that do what?
That add up to 3.
Not add. What's that sign right there?
Subtract.
That's what matters. If that's a subtraction sign, then they have to subtract a 3. If that's an addition sign, a plus sign, then they have to add the 3. But in this case, okay, let's go over here and figure out our factors of 28. We always start there. Cut that in half, double that, do it again. I just found them. I'm looking for factors of 28 that subtract to the number 3.
Yeah, 7 and 4.
Now, there's one more step. You have to decide where the 7 goes, with which sign, and where the 4 goes. The larger factor, the 7, goes with the sign of the middle term. There you go. if I take that and multiply all three of those together, I'm going to end up with what I started with.
Mm-hmm.
Okay. What else?
Uh, 2x squared minus 6xy minus 9y squared.
All right. It's a little different because it's got, we don't even need that. That's all they gave you, right? And they just said
Yeah.
factor it.
Mm-hmm.
Okay. First of all, is there a greatest common factor? That's always what you want to check.
Yeah, 2, right?
No, I cannot divide 9 by 2.
Uh,
In other words, the greatest common factor has to be divisible evenly into every term that you're looking at. I got 3 terms. I got 2x squared, I got minus 6xy, and I got minus 9y squared. So if I could find something that divided evenly into all 3 of those, I would take it out, always, because it simplifies it. But there's nothing there. So we're back to our first step, second step, third step, fourth step. What's the first step?
separate the x's.
Okay, how can I separate those x's? What does one have to be? What's the other have to be? Remember, they have to multiply to 2x squared. That's always the first step. When I'm going to multiply these things back together again, is the 2 n terms. That's my first term. So one of them has to be 2x, the other has to be x.
Oh, okay.
Okay, because when I multiply these together, I get 2x squared. That always is the first step. Is when you separate the x's, they have to multiply back together to get what you started with.
Mm-hmm.
Second step.
Find the signs.
What are they?
Both negative, right?
No, that would be positive if both signs were negative. Remember, you are doing the reverse of FOIL. You cannot produce a minus 9y squared if both signs are the same. It would be a plus. That's a key understanding in this factoring business, is that the most important thing you look for is that sign right there.
Mm-hmm.
That is absolutely key in determining what both signs have to be. Well, both signs have to be opposite one another. So one has to be plus, one has to be minus. That's the only way I'm getting a minus there. Now, in this problem, this is not a first level factoring problem. This is a second level, because this number right there is greater than 1. Now, when that's the case, then plus minus is not the same as minus plus. So I kind of have to allow for both possibilities. So above I write plus minus, and the other possibility is it could be minus plus. And I'm going to narrow it down. Okay.
Okay.
Now, we're looking for factors of 9y squared. Well, that could be 9y and 1y. That could be 3y and 3y. And that's it. That's the only 2 possibilities. So, because this is a second level quadratic, I got to throw out the window all those statements that I'm looking for factors of 9 that subtract to the number 6. They no longer apply. You cannot use that on these kind of problems. This becomes a trial and error process. Now, what I usually tell people to do is always start with the 2 factors that are closest together. Well, 3 and 3 are closer together than 9 and 1, right?
Yeah.
So let's just try 3 and 3. And it's completely random. I can start anywhere. I'm just going to try all 4 combinations of that until I try one that produces that proper middle term. What's the middle term if I try 3 and 3? Again, we want the middle term. That's going to be plus 3x, multiplying the insides. And when I multiply the outsides, that's minus 6x.
Mm-hmm.
Well, that's minus 3x. That's not our middle term. And
Yeah.
we obviously are going to need a y with it. In other words, I need a y there. But even when I add the y, I still get minus 3xy.
Mm-hmm.
So that's not correct. So 3 doesn't work there. If I put 3 down below, I'm going to get the same thing. I don't know if you can see it, but one of these 3's is going to multiply the 2. The other 3 is going to multiply the 1. They're always going to be opposite signs, so I'm always getting minus 3xy. So what that tells me is my factors are not 3y and 3y. Well, there's only one other thing to try. Let's try 9 and 1. What's that produce for a middle term?
8.
Okay, I got a plus 9y times a minus y. That's minus 9y xy rather. Here, let me do this over here because I'm running out of room and I can't erase. So I'm going to rewrite it just to show you what I'm talking about here. So my choice is, if I'm going to try 9y there and 1y there, well, that will definitely multiply together to give me this minus 9y squared. So that works for producing the correct last term. But what we need is the correct middle term. Okay? Remember, the middle term always comes from the 2 inside and the 2 outside. Well, that inside is plus 9xy. The outside is minus 2xy. Well, that doesn't work either. Why are they giving you this problem? This is not a problem for the level of factoring you're on. Jameson, what algebra are you taking algebra 2?
Geometry.
Taking geometry. They're just reviewing factoring?
Mm-hmm.
Okay. This is not a good one to review because this doesn't factor. You would have to use the quadratic formula, which is even tougher because there's 2 different variables. There's x and y. So this is like 4th level of factoring. Instead of what you really need to be working on, which is 1st level, 2nd level, and maybe 3rd level, but not 4th level. And when you have both variables like this, unless I made an arithmetic mistake here, and I don't think I did, there's no way I can produce that middle term by factoring it. Which means it goes into the realm of using the quadratic formula. Are you familiar with the quadratic formula?
Yeah, I am.
Okay. Well, that's something we should talk about next time. And the reason is that, here, let's go back to level 1. If I gave you this, I'm just going to take 2 more minutes of your time here.
Okay.
I can't factor that. There is nothing that works. I can try x minus x plus, but then I'm looking for factors of 4 that subtract to 2. Well, there aren't any. Factors of 4 are 4 and 1 and 2 and 2. Neither of those subtract to the number 2. So what that tells me is I cannot factor that quadratic. I got to use the quadratic formula.
Mm-hmm.
And then I can factor. I can come up with the answer, but I've got to go to this super complicated thing that everybody hates. So if you can't factor it normally, in other words, into linear factors, then you're going to end up having to use the quadratic factor. And we will talk about that later. But even this, that's level 3 at most. The problem that you just gave me before this is level 4, and it's 2 variables. So I'm not even sure I know how to do it. They shouldn't certainly be giving it to you as one to do. If they are, somebody's screwing up. If you're taking geometry, there's no way you should have been given that previous problem that you gave me that had both an x and a y. 2 problems with it. First of all, it didn't factor. Second of all, how do we use the quadratic formula when there's 2 variables? So that problem is a beast, and I'm not sure. I can't believe they actually gave that one for you to do for homework or anything. Just, it doesn't work. I couldn't find any combination. There weren't that many factors of 9y squared. It's 9 and 1 and 3 and 3. That's it. And neither of those produced that middle term. So that doesn't factor nicely.
Yeah.
And you don't want to be dealing with 2 variable expressions that don't factor nicely. Like I said, I'm not even sure I know how to do that. Not even with college algebra do I know. I'm not sure I know how to do that.
Wow.
But you definitely should not be getting that problem in geometry. Okay. Jameson, I'm going to let you go. We were only scheduled for a half hour today, correct?
Yeah, I think so.
Okay. And hopefully I've helped a little bit on your, if you can master elementary quadratics, you're going to be in great shape. Trust me. Any tests they ever give you on factoring, it's going to have, for every 10 factoring problems, 9 are going to be simple elementary quadratics where you can use that method I taught you that either has 3 or 4 steps. And that's it. They may give you one that has a 2x squared, and even that one I can show you how to do, but it's got to be one that only has 1 variable, not 2 variables.
Right.
So we can work on that next time. The best thing to do when we have a session is for you to have whatever problems you want to go over in front of you ready to go. So that either you can read them to me or take a picture of it and send it to my email. I'll bring it up on the screen, and then we can do them.
Okay.
Okay? Jameson, you have a good rest of your weekend, and I will talk to you next time.
All right. Thank you.